Hi, topic for this session is computer architecture. First, to understand the architecture, first we need to understand the concept of abstraction. Abstraction is a Latin word that describes the process of removing unnecessary characteristics in order to reduce it to a set of essential or required characteristics only. So we use the concept of abstraction to take a relatively complex system and simplify it for our use. So we are not actually reducing the complexity of a system, we are only reducing the complexity for the user to work with the system. So we use abstraction in everyday life and you may not even know it, right? For example, when we drive a car, we aren't worried about the internal functioning of transmission technology or internal working of its engine. Same concept is the base in computer as well. So we mostly interact with mouse keyboards without going into the internals of the hardware functioning in binary numbers. End user doesn't worry about the technical details. Even when we receive the error message, it's displayed in the user understandable form, hiding the internal of it. For example, file not found error message is displayed without going into the code and bugs in the application. For instance, when we use a notepad and we get some error, the file is corrupted or something, so it doesn't display the hardware issues of displaying the error. So computer can be described as the layer of abstraction. So let's understand the layers of computers and how they work. It's divided into 4 layers. At the bottom we have hardware, then we have system softwares, or we may say device drivers for these hardwares below, or operating system. Above system software we have application software. These are the software that we install over the operating system we are using. That could be Microsoft Office, that could be Skype, that could be Zoom, that could be a notepad, right? So above this application software layer we have users. So user, while interacting with computers, usually interact with these softwares installed above it. So for example, we are working on Microsoft Office to create a PPT, or we are working on a software installed on a system to create this video, right? So user doesn't directly interact with the system software or the hardware. So hardware, this layer consists of physical or tangible components of the computer. That is what we can hold, like keyboard, mouse, printer, or memory cards. This is manufactured by different companies. Then we have system software. This layer allows hardware to communicate with the system regardless of who manufactured it. Examples are operating system that has immediate interaction with hardware, such as Android, Windows, Mac, and Linux. Then we have application softwares that we talked about. The softwares layer applications is through which user interact with computer. Large amount of softwares are available for performing specific tasks like CAM scanner app or web browsers like Google Chrome, word processors for mobile or a laptop. At the top layer, which is the most important layer, is the user. This is an important layer of computer architecture. User not only interact with computer but can operate, maintain, and even instruct the computer what to do and when to do. So human element is very important, as that is what make a job done by a computer. So user is not only using the system, even it train the system how to work on certain scenarios. So going to the first level at the bottom we have hardware. So now we'll try to understand the hardware components of the computer. So here's a block diagram of computer, right? So it has input, output, and a CPU in between. It's called central processing unit, which consists of 3 things: control unit, arithmetical and logical unit, main memory, and we have some extra memory required by a system as auxiliary storage or secondary storage. So input devices are one that accept the data and instructions from outside world. Device drivers are softwares we talked about, convert the instructions to system acceptable form. So whenever we press a key on a keyboard, there's a signal that goes into the system, and these device drivers actually convert those set of signals that goes from a keyboard into a form that machine can understand. Probably that could be a machine language, and also supply that converted data to the computer system for further processing as discussed. So these are examples on the right hand side of some of the input devices like keyboard, mouse, joystick, stylus, webcam, barcode reader, mic, touchpad, touchscreen, or a fingerprint reader. Then we have output devices. Device drivers of the output devices accept results from the computer system which is in a machine language, and these device drivers convert this machine language data into a human readable form and then forward that to the output device for display, printing, or listening. Some of the output devices displayed on the right hand side are monitor, printer. Monitors can be of different type. We have headphones, speakers, projectors, and CD-ROM, right, for writing the data. Then we have central processing unit, which is the middle part, if you do remember in the block diagram. It's a think tank or the brain of the computer. It has three main components actually. One of them is a memory that we'll talk about in the sessions to come. Rest two are arithmetical and logical units and control units, which jointly is known as central processing unit. The CPU's ALU part or the arithmetical and logical unit performs actual processing of data, to which we even call a processor, right, according to instructions from the program. It performs calculations and take decisions as per the pre-fed instructions. So machine doesn't have a instruction what to do and when to do. This is also been fed by the user. That's why I told you user is a very important component of the computer system. The control unit works as a central nervous system of the computer that controls and synchronizes each part, right, of computer, its working and flow of data instructions among components of the CPU.